Good morning, students. Welcome back. Today we'll discuss product of vector. In this chapter, motion straight line. As you know, last time we did the addition of vector. Okay, we did the resolution of vector. Now we can add the vector. We can divide the vector. We can split the vector. Now we can also product the vector. So let's start. We'll start product of vector. Basically, these are two types: scalar or dot product, and second is vector or cross product. So today we'll discuss first of all first point, scalar or dot product. Okay, what is the definition of dot product? Listen, when two vector quantities are multiplied, when multiplication of two vectors gives the result scalar quantity, such multiplication, such product is said to be scalar or dot product. Look at it. Force is a vector quantity, displacement is a vector quantity, but when we multiply, it gives the result work, that is what? Scalar. So if the multiplication of two vector quantities give the result scalar quantity, such product is said to be scalar or dot product. It is represented by dot. It is having a mathematical form a dot b equals to ab cos theta. That is a mathematical form of scalar or dot product. Whenever we remove dot, there always comes cosine cos theta. Okay. Now let's start the property. The first property, it follows commutative law. It means a dot b will always equals to b dot a. The result will not change. The magnitude will not change on changing the order. Second point, that is one of the most important point. Numerical will be based on this point. The scalar or dot product of two perpendicular vector is 0. It means if vector A is perpendicular to vector B, okay, theta will be 90. And cos 90 will be what? 0. So the dot product will be what? 0. That is one of the most important point. Remember, if two vectors are perpendicular, their dot product will be 0. And finally, the dot product of two parallel vector is unit. It means like vector I dot I, j dot j, k dot k should be 1. How? Suppose we are having I dot I. When you remove dot, there comes cos theta. Okay, this is like vector, parallel vector. For parallel, theta is taken 0 for parallel vector. Okay, so cos 0 is 1. There remains I square. I is a unit vector. We'll put 1 square 1. In this way, if two vectors are parallel, their dot product will be what? 1. Okay, unit. So these are the basic properties and definition of scalar or dot product. Okay, students.